This is pre-AP Precalculus. This is free response practice number 42. You're allowed to use a calculator. Consider the trig functions f of alpha and g of alpha. Find the values of both f of 3 pi over 4, or 3/4 pi, and g of 3/4 pi. Round your values to the nearest thousandth and state why the conclusions can be made about the domains and the graphs of these functions. Well, although this says to round, I don't know if I'm going to do that because 3/4 pi, that's a special angle. So we can figure these out without a calculator. So I'm going to do that without a calculator. So we're supposed to figure out what f of 3/4 pi is. So that's going to be secant of 3/4 pi plus tangent of 3/4 pi over secant of 3/4 pi minus tangent of 3/4 pi. Well, let's review what we know about 3/4 pi. You know that's in quadrant 2. You know the reference angle is pi over 4. There's a couple different ways you can do this. I'll show you both. You could assume it's a unit circle with the radius is 1. And I think that you all know that makes this square root of 2 over 2 and negative square root of 2 over 2. I personally, it's not my bag. It's not how I've ever really done it, but I teach that because that's how it's universally taught. I prefer not to make it a unit circle and to make the smallest side of the triangle 1. That makes the hypotenuse square root of 2. The end results are going to be the same. We went left here, so that's negative. So figuring this out, secant of 3 pi over 4, that's going to be r over x. So that's going to be, depending on your perspective, that's going to be 1 over negative square root of 2 over 2, which simplifies. Or if you use this circle, it's going to be square root of 2 over negative 1. Both of those reduce to negative square roots of 2. Plus tangent of 3/4 pi. Well, tangent is y divided by x. That's 1 over negative 1, which is negative 1. Divided by, we got the same expressions, but we are just subtracting. So that's going to end up being 1 minus the square root of 2 over, I'm sorry, that's not right. If we factor negative 1 at the top, we get negative 1 times square root of 2 plus 1. On the bottom, that's going to be negative square root of 2 plus 1. If we factor negative out of the bottom also, we're going to have negative 1 times the square root of 2 plus 1. Factor negative 1 out of the bottom, you're going to get square root of 2 minus 1, but you don't have to do that. So this ends up being square root of 2 plus 1 over square root of 2 minus 1. One way to write the answer. We're supposed to also figure out what I wrote that pretty big, what g of alpha is. I'm just going to move this over here in the middle. So g of 3/4 pi is going to be 1 plus 2 sine of 3/4 pi plus sine squared of 3/4 pi, all divided by cosine of 3/4 pi. Once again, the directions, find these values. So I'm trying to find them. What is sine of 3/4 pi? I'm going to choose to use this version of my picture for this, so I don't have to simplify anything. So 3/4 pi is square root of 2 over 2. Plus, I'm going to have another one of those, and that's being squared this time. And this is over cosine squared root of 3/4 pi. Cosine of 3/4 pi is negative square root of 2 over 2. It's being squared. Let's try to simplify this. I'm going to get 1 plus square root of 2 plus 2 fourths, which is a half, over 2 fourths. Simplifying, we're going to get 1 plus square root of 2 plus a half over a half. If I multiply the top and bottom by 2 and distribute it to get rid of this denominator, it's going to give me 2 plus 2 square roots of 2 plus 1, which gives me 3 plus 2 square roots of 2. The directions said to write the answer into the nearest thousandth, so I guess I will be respectful of the directions and do that. So if I take square root of 2 plus 1 over square root of 2 minus 1, sometimes this calculator doesn't work well because my handwriting's so beautiful. That's going to give me f of 3/4 pi is about 5.828. This other one is going to be 3 plus 2 square roots of 2. Oh, look at that, which is about 5.828. Oh, it's the same answer. So the question said, find those, which we did, and state what conclusions can be made about the domains of these graphs. Well, the only conclusion that I can make about the domains of the graphs is that 3/4 pi is in the domains of both f and g. Since f of 3/4 pi and g of 3/4 pi have numerical solutions, three-fourths pi is in the domain of G and F. I'm sorry for the terrible handwriting. Let's just check the rubric, see if that's saying the same thing. Oh, I guess there's more that we could say, but really not about the domain. Oh, it says about the domains and the graphs. So let me just cheat here, because that's how I was raised. We can conclude about the domains. What can we conclude about the graphs? Well, the graphs must intersect at this point because they're the same x and y value. G and F must intersect at 3/4 pi 5.828. It's interesting that this answer and this answer look so different, but it's the same value. It's pretty cool, if you ask me. That's good enough for A. B, find the values of these, round your values to the nearest thousandth, and state what conclusions can be made about the domains. So let's do that. So f of pi over 2, let's see what, I'm just going to copy this function down. And replace these with pi's over 2. Pi over 2 is the positive y-axis. This location, x is 0, y is 1, and r is 1. Secant of pi over 2 would be r over x, that's 1 over 0, that's undefined. Tangent of pi over 2 is y over x, that's also undefined. So this is undefined. What's that mean about the domain? It means that pi over 2 is not in the domain of that function. Let's try g of x, which is this function. Just put pi over 2 into this, so I'm going to replace these angles. Pi over 2. Let's just focus on the denominator. Cosine of pi over 2, that's 0 squared. Not good. This is also going to be undefined. Sine of pi over 2 is 1. Oops, that's not sine of 1, it's just 1. And sine squared of pi over 2 is going to be 1 squared. So this is also undefined because we're dividing by 0. What conclusions can we make about the domains? Pi over 2 is not in the domain of f or g. What conclusion can we make about the graphs? Well, let's see. We can say that there are vertical asymptotes here. I think that's what we're going to say. I guess we don't know that for sure. We could say that the graphs of f and g are discontinuous. At x, was this x? Alpha. At alpha equals pi over 2. If you know about anything about the graphs, you would know the vertical asymptotes, but just in general terms, from the information just in here, if we didn't have previous knowledge, we would know it's discontinuous. Could be a hole in the graph, could be a vertical asymptote, but discontinuities cover both of those. Good enough. Part C. Show analytically that these are equal for all values of alpha. Oh, it's a thing that we just did. Awesome. I'm going to start with the left. You know what? Let's get crazy. I'm going to start with the right. The right is not more complicated. But I recognize this is a perfect square trinomial. This becomes a 1 minus sine of alpha quantity squared. More compact. Now I'm going to work with the left, and I'm going to change everything in terms of sine and cosine. Secant of alpha is the same as 1 over cosine. Tangent is the same as sine over cosine. I already have common denominators on the tops and the bottoms. So I'm going to have 1 plus sine of alpha over cosine of alpha. 1 minus sine of alpha over cosine of alpha. To make this not complex, I'm going to multiply it by 1 in the form of cosine of alpha over cosine of alpha. Those cancel, and that leaves me with 1 plus sine of alpha over 1 minus sine of alpha. Not much more I can do with that, so let me go to the right side. 1 plus sine squared of alpha in my numerator is the same as 1 plus sine of alpha times 1 plus sine of alpha. The reason I want to focus on that is because the left side has one of those. Need to get rid of the other one. Cosine squared of alpha can be replaced with 1 minus sine squared of alpha. That's a difference of two squares, which factors into a 1 minus sine of alpha and a 1 plus sine of alpha.
Teachers, please excuse this interruption for a few quick announcements. First of all, Jacob Reed to the main office, please. Jacob Reed to the main office.
Cancel this from the top and the bottom.
With the fifth period 5B study hall is going to be larger than normal. So 5B study hall today will be in the auditorium.
Both sides are the same.
B study hall.
So we are finished.